So Dale has some money and he wants to invest it, and he has a goal of getting $2,500. He starts out with $1,000, and he wants to get that in 10 years. So at what annual rate does he need to reach his goal? So the first thing you realize is this is an exponential function because we're talking about compounded continuously interest. So we remember that the compound continuously formula is this. Amount equals the principal times e to the RT. So remember, this is our amount. This is our principal. E is the Euler's number. It's just a number. Rate, R is the rate, and T is the time in years. So let's fill in what we know here. We know that he wants to end up with $2,500. We know that he's starting with $1,000. And we know that he wants to take 10 years to get there. Or at most 10 years to get there. And so now we just don't know R. And so see, we have this R and it's stuck up in our exponent and we just don't know what to do with it because we don't actually have a tool. We can't take like the rth root of something or something ridiculous like that to try to get R by itself, right? It just doesn't work. So we need to solve for R, and that's where logs come in handy, is when we want to get R out of the exponent, we can use logs to do that. Okay. So first things first, let's take the ln of both sides. And the reason I chose ln rather than log is simply because I noticed that this has an e. Actually, before I take the ln of both sides, I need to do something else. I forgot that step. But I noticed that this has an e, so that tells me that I'm going to be, let's use ln rather than log because we have a base of e. But I can't take the ln of both sides because e is not by itself right now. So then I would have like the ln of 1,000 plus, and it would be complicated, right? So let's just divide both sides by 1,000 right now so that it's easy and I don't have to deal with that extra number. So that 2,500 divided by 1,000 is 2.5 equals e to the 10r, and that makes sense because he wants to have 2.5 times what he started with, right? Okay, so now I'm going to take the ln of both sides. And again, the reason I'm using ln is because I see the e and that base, ln is log base e, so I want to get rid of that e. So let's take ln of 2.5. Ooh, that went nuts. Okay, oh, it's like my left-handedness is getting in the way. There we go. And the ln of e to the 10r. Okay, so then we can use our exponent rules for logs and realize that this can come down in front. So I'm going to end up with ln of 2.5 equals 10r times ln of e. Now, what is the ln of e? You might have that just right off the bat, but if you don't, remember that ln is log base e, and so we have ln of e equals what, right? So that means what exponent do I need on this base to get the argument, okay? So the base is e. What exponent do I need on e to get e? Well, it's 1, right? So I have ln of 2.5 equals 10r times 1, which is just 10r. Okay, so now we took the ln of both sides, and let's just get r by itself, okay? Remember, ln of 2.5 is just a number. It's a number we can just plug into our calculator because we have an ln button on our calculator. So let's divide both sides by 10 so we can get r by itself. So I end up with ln of 2.5 divided by 10 equals r. Now I can just plug this into my calculator. So let's pull up our calculator. Calculator. Okay, so we pull up our calculator and we do ln of 2.5. Now make sure you close your parentheses because we're not doing ln of 2.5 divided by 10. We're doing ln of 2.5 divided by 10, right? So ln of 2.5 divided by 10. And we get 0.091629. Let's write that down. So we get 0.091629, right? Okay, so what is the rate? This is R. What is the rate that we need to have this at? Well, if we write this as a percentage, we bring this over 2 decimal places, 9.16%. So I would say at least 9.16% is probably what he needs. Maybe 9.17 just to get there by 10 years. But there you go. That's how we use the log to solve exponentials and word problems, which I know you love, but it's actually really useful, right?